So we know there's a memory leak, but we need to figure out what piece of code is causing it. Well, this is where heap snapshots come in. They show you a snapshot of the current JavaScript objects in memory so we can figure out where the leak might be. To take our first snapshot, we'll go into the Profiles panel, select Take Heap Snapshot, and press Start. We're currently in Summary view of our heap snapshot, which shows us all our objects, but this is quite a large number to sift through. Instead, let's take a second heap snapshot and then we'll compare it to the first. But before we do that, let's go ahead and go through our application and do the behavior we think might be causing that memory leak. So we'll open and close the form a few times. Now back in the Profiles panel, we can just hit the Record button at the bottom of the screen, which will take another heap snapshot. Then, to make this comparison, we'll select the newest snapshot, switch the view from Summary to Comparison, and make sure it's comparing against snapshot 1. Now we're looking at objects that were allocated between our two snapshots. The detached DOM tree item listed right here is especially interesting. If we expand it, we'll see a large number of input elements. They're highlighted in red here because they have been removed from the DOM, but they haven't been garbage collected. The memory that they were using hasn't been freed up. While there can be legitimate reasons to do this, more often than not, there's a memory leak. If we dive into our source code, we see the first signs of our problem. Whenever we're creating the form for adding an event, we're creating the inputs from scratch. Then we're adding a function to the window which listens for the escape key to be pressed, and then removes the form fields by just overriding the parent's HTML. There's two issues with this listener. The first is that it simply removes the input fields from the DOM when it overwrites their parent's HTML context. That causes these elements to be detached as you see here. They're no longer connected to the DOM. Ordinarily, the garbage collector would come along and delete this node the next time it cleans it up. However, we also have the reference to the input fields within our function, which is in turn attached to the window object. The garbage collector sees this reference and doesn't clean up the inputs when it runs. It just leaves them there until such a time that the page is closed or reloaded. It is a memory leak. Every time we hit the Add Event button, it's creating new input fields, and then when we press Escape, it's never cleaning them up. So how do we fix this? Well, it's probably optimal to keep the input fields in the DOM all the time. Just have them there and show them when we go to add a new element and hide them when we don't need them anymore. Also, we should make sure we're not creating new elements outside the event listener, which we're using inside the event listener. So let's take our input fields out of our JavaScript and we'll put them into our HTML. We'll also move our Add Event button into a separate container, so it can be hidden when we show the create form. Now we'll go into our CSS and make sure the creation form isn't displayed initially. It starts out as hidden. Then, back in our create method, we'll add the code to find our hidden create div and show it. Then we'll find the add button and hide that. Inside the escape key listener below, we'll first get rid of the code that overrides the HTML, and then simply hide the creation form and show the add event button. You might notice that we still do have reference inside the event listener of create and add, even though they were declared outside the function. Let's fix that. It'll be safer to do a fresh lookup of the nodes every time. That way there's not an extra reference to these nodes inside our event listener. Now let's see if our code works. Looks like our changes are working. Now let's see if we're leaving detached DOM nodes still. We'll return to the Profiles panel, take another heap snapshot. Now we'll do that same activity before that created a memory leak. We'll display and hide the fields a few times again. Then we'll take a second snapshot, select it, choose the comparison view, and then compare to the previous snapshot. If we look at the objects created between the first and second snapshots, we can see that we're no longer leaving detached DOM nodes when we hide our fields. Sweet! So now we've shown you how to discover memory leaks, pinpoint them, and eliminate them. It's time for you to try it out in the challenges.